I'm going to start with some core functionality that we have inside SpaceClaim. And the first place I'd like to start is just a run through of some tools that have been a strength of SpaceClaim for a long time. So what many of you might know is some of the core strengths of SpaceClaim are related to its ability to link together industrial CAD that you have to build and simulation CAD, which often has to be quite simplified, has to have a fair amount of cleanup happening to it. So in this geometry here, we've got a staircase example. And this is one of those candidates that if you kind of zoom in here, you'll see it's a 3D geometry. It's made up of a number of thin components. There's some girders and platform pieces here. And so this is a candidate for mid-surfacing. So what I'll do here is I'll just work at removing these unnecessary components. These are kind of the handrails that don't really play much of a part in the geometry. And so what we can do with these is we can take this selection and we can say any body of the same color is something we want to delete, right? So it's simple tap on the delete key for that. As far as mid-surfacing goes, we do need to look at a couple of things. One could be the thickness of the material that we're looking to thin down into shell elements. So I think this is probably our thickest material here. You can see down here when I probe these two surfaces, it tells me the thickness is about 32 millimeters. So I'm going to use that in my mid-surface tool. This is on the Prepare tab where a lot of the FEA and CFD ready tools are. And so if I click mid-surface here, it's going to ask me if I choose to use the range. Now I could use manual, but this is a fair amount of work to do here. So like we said, it was 32 millimeters. If I pick 35 and enter it into that box, then by nominating the geometry here and pressing go, you can see just how much work SpaceClaim's doing for us. There's at least 80 of these bodies to shell out, and it's gone ahead and it's done them in 5 seconds maybe, right? So the end result here is 2D geometry that we can clearly see has some gaps. Now that's a pretty common thing to happen when you reduce 3D geometry down to 2D. So there's the tools here to help with all that as well. So again, I'm just going to check distances, and I can see, I go to my measure tool here. This will probe the distance that we're looking to close up. That's 43 mil. So if I go back to Prepare tab and I pick the Extend option here, this is asking for a max distance. So I'm going to enter 50 mil here, and I don't mind too much if there are partial overlaps in the CAD geometry and if I have to trim any surfaces down. So I'll pick partial intersections there. Now you can see it's actually picked 250 of these areas that we'll need to fix. So this will probably be a two-step operation. The first 250 get fixed on the fly here. And you can see when it's done, it's still got 74 more to go. So I'm going to click that and fill that in. There may be some pieces left at the end which require manual resolution if it's not quite sure how to close up the final gaps, but as an exercise in being able to prepare something from 3D all the way down to shell elements in short order, it's a pretty good example of just how quickly you can do that, right? So this is a way of shelling down to 2D. I'm going to Control Z a couple of times here. I'm going to go back to the 3D geometry. And this could also be a candidate for solving beams on. Instead, you could be looking for beam elements instead. And for that, you're probably considering the main structure. So you're looking at the gray and the green solids here. So if I was going to do beams, then the first thing I'd want to do is just hide the blue solids here. So if I go to the same color and Control H those, I can now hide those away. Now the beams are in the same Prepare tab and you'll find them on the extract toolbar option here. And so again, it's just asking me to nominate the bodies of interest, and it's gone ahead and it's extracted beams for all of those. Now you can actually end up with some bigger gaps when you do beams. Extend is another option that we have here. In my trials, I think I found roughly of the order of 125 was able to fill most of the gaps. I'll just show you an example of it doing that. You can see these actually might need manual closure, but for the vast majority, you can iteratively work through and you can close all of these problems up, right? So fairly complex assembly, lots of components, shelled and beamed in, in just a few minutes is a nice tool to be able to have. I'll just show you quickly as well a more of a general purpose repair that we could do. This is on a turbine blade. So this could be of interest to FEA or CFD people, really. This has come in to SpaceClaim as a series of surface bodies. Now the intention here is probably that this should have been a solid geometry. And it can be fairly common to sometimes get these coming through for complex assemblies. It could be that there's a translation error. It could be a user error, or it could just be a tolerance issue between your software. So there's a set of tools here on the repair tab that are worth just reminding you of. So stitch is the first one. And this is just looking for surfaces which are touching and could be combined together. Now, commonly the stitch will actually completely fill in your geometry and you have a solid body at the end of it. In this case, we're not so lucky. You can see it's still a surface body. So we can look at this gaps option instead. Now, gaps is really looking for quite small distances. You can configure the distance yourself. So this one here, it's pretty small. It's pretty hard to be able to see that. And actually up here, there's another one, which I think we can just isolate with a slightly larger tolerance. And you can selectively pop in here and fix these by mouse click. Or you could just have clicked the checkbox to do everything at once. So we're still a surface body. So the last thing to look at is missing faces. Missing faces can do a couple of things. It's very good at picking just obvious mistakes. So perhaps somebody forgot to fill these solids in here. But it's also good at still spotting small regions that maybe gaps didn't find out for you. And so you can step in there and you can repair those as we see there. Now it still could be that you look at that and say, well, I don't really fancy meshing that. It's got a tight corner. It could be something that gives my mesher some potentially poor quality elements. So the fill tool can be used to take care of things like that. So there's the fill, just taking care of the operation there. You can see over here we've got a solid body. Now, if you're a fluids person, you might then look to prepare this for a CFD study. So you can do that with the Prepare tab again. I'm going to show you Volume Extract. Enclosure is available as well for external flow. Volume Extract is for internal. And the idea with this is that you pick the surfaces that you know are on the outside where fluid can leak out, and then you just pick one surface anywhere on the inside. Now I'm going to leave a deliberate mistake in just to remind you that you can use this tool here called Preview Inside Faces. And what that should do is it should paint red anything that's inside the geometry, right? So the fact that I'm covered in red paint here is actually a sign that there's a mistake or there's a gap somewhere. So we can wind this back. I'm going to kind of just drag this back. And as you replay it, you can probably just see it coming through those cooling holes there. You can also hit the play button here and try to visualize the same thing. So that's a sign to me that I need to cover these holes up as well. And then having done that, the volume is extracted properly, right? So from here, you can do all of the things that SpaceClaim is so well known for, easy manipulation. We could decide to extend these inlets or outlets just by pulling them. We could decide that for the first study, maybe we're not going to consider the cooling holes. Well, for that, we'll just pick our radius protrusions and we'll use that fill tool to take care of that, right? So that can all be done easily. Fillet removal is quite easy as well. We can double click to get edge loops, as we see here, and we can tap F, and that can take care of filling those in as well.